What's up, 8th grade math? Catlin here with your help for your cool down video. We're looking at systems of equations, and we're going to do this milkshake problem revisited from our warm-up problem today. And determined to finish her milkshake before Diego, Lynn has upped her speed. She's now drinking her 12-ounce milkshake at a rate of a third of an ounce per second. Diego starts with his usual 20-ounce milkshake and drinks at the same rate as before, which is 2/3 of an ounce per second. All right. It wants us to graph this situation on the axes that are provided. And what does the graph tell you about the situation and how many solutions are there? So let's start off by making a little table. We already did this for Diego in class, but let's knock it out again. We got ounces versus seconds. These are our units of measure. And Diego is knocking out 2/3 of an ounce every second. This is Diego. And we found out in class that for him to finish his full 20-ounce milkshake, we multiplied by the constant's reciprocal because that's our constant to get over this way. So we could multiply by 3/2 to get back or divide by 2/3. And that told us that he was going to finish in 30 seconds. So we know that Diego is going to down this 20-ounce drink, which, is where he starts. It's going to take him 30 seconds to get it done, which is right here. So we can graph Diego's line by making that, not that shape, undo that. Let's make it a straight line. So we go from that point to that point. This line represents all of Diego's milkshake drinking. All right, so let's do one for Jada now. Jada, her table is going to change a little bit now because Jada is now drinking her milkshake at a faster rate than she was before. 1/3 is greater than 1/4. So you're going to make this a little bit fair of a match between the two as they try to drink them. So let's see. We got ounces and seconds. She's now drinking hers a third of an ounce per second. So 1/3 of an ounce every second. That gives us a constant of 1/3. And if we want to know how long it's going to take for her to finish her 12-ounce milkshake, we need to reverse that and multiply by the reciprocal to come back. That would be 36 seconds. Jada, you were close, but you're going to take 36, which is right here to finish. And you started at 12. And you're still drinking it slower, but you made it much more fair this time. It was a closer race than the last time. And so when we connect those from 12 to the 36, we can notice that she's still drinking it slower, but taking longer to finish than Diego in comparison. And it says, what does the graph tell you about the situation? We can see where they start, where they finish, speeds. Let me write those things down. We can see starting points. We see starting points. We see finishing points. We also see the speed at which they're drinking. And we see intersections of where they actually have the same amount in their cup at the same time, which would be right here. And that would tell us that there is one solution. So there's one solution to this system. And that's what we've been talking about. If they cross like this, there's one solution. If they're parallel, they never cross, there's no solution. And if they are the exact same rate, same line, then they have infinitely many solutions. And that's a quick tutorial on how to do lesson 12 cool down. See you guys tomorrow. Later.